Okay, so now that we have all of our data written out for us from the last video, we can start making some generalizations about what this really means. So first let's compare the data that we have for x and x plus 3 and see what it means when we add a constant or subtract a constant from a data set. So first let's look at the mean. The mean here is 27.2, but in this set it is 30.2. So the mean has increased by 3 since you added it to the entire data set. The median as well, since it was 25.5 and then it increased to 28.5. But the standard deviation and variance stayed the same for both data sets. And this makes sense because if you increase all the values in a data set by 3, then the distances between those specific values don't change. Only the values themselves do. So generalizing, we can say that when a constant is added or subtracted to a data set, the mean, median, and also quartiles of the data change, since the quartiles are related to the median. They change by the addition or subtraction of that specific constant, even though standard deviation and variance remain the same, as I already explained. So now let's compare the data set of x to 2x and see what happens when a constant is divided or multiplied to a data set. So looking at the mean again, we have 27.2, and here we have 54.4. So we can see that the mean doubled and the median doubled as well. Standard deviation actually doubled too, and then the variance quadrupled. So for this data set, we can say that if a constant is multiplied or divided to a data set, the mean, median, quartiles, and standard deviation are all multiplied by that constant. And the variance is multiplied by the square of the constant. And that's why the variance is quadrupled. It is multiplied by 2 squared, which is 4. And that's why the variance is so huge. For me, this is a lot easier to remember if you think of everything conceptually. If you multiply or divide a constant to a data set, then the values in that data set are more spread out or more concentrated, because if you multiply the data set by 2, as we have, then the data set is twice as spread out as it was. That's why standard deviation is doubled, because you can see that the data is a lot more spread out than it was before, twice as much to be exact.